Hello everybody, we are continuing the video. This is part 2 of the implementation series on the Servo.j on how to use the RTDE Exchange data package. I'm going to divide this video into another 2 parts because what I'm going to explain is quite complicated, and I just want to make sure that everything is as clear as possible. If you have any questions, feel free to ask me in the comments below. I will make sure to reply to you. So let's understand first what we are trying to achieve, okay? Imagine you're coming to work, you turn on your robot is in some initial position, right? It has some initial TCP, pause, or it has also initial join values. This is state A, this is state that you did not define. This is the state of the robot that you left it last time that you worked on the robot. So our first task, also we will call it mode, is going to be move from this initial random state to define state B, which will be our start position, using command move_j. Okay, so we are going to, using Python, we are going to send the values to the registers that will move the robot to point B. And then in the task 2, we are going to implement our minimum jerk trajectory, and we are going to follow it using the servo.j command and move the robot from point B to point C in a smooth fashion. And then the mode 3 will be stopping the program, and basically after we arrive to point C, we are going to stop the program and the task has been done. What is very important to see, please look on the left side over here that you can see, is the general explanation on how the program on the polyscope will be structured. So, because we are communicating between the external device and the robot, we are going to have 2 programs running at the same time. We are going to have a program in the Python on our external device, and we are also going to have a program on the polyscope. So basically, the function of the program that we wrote on our external device is to send the values to the registers, and those values are going to be read using the polyscope, and then whatever the values we sent, we are going to plug to the functions that are defined on the polyscope in the polyscope program, and then the robot will execute them. This is one of the big differences between real-time and RTDE. RTDE, from what I read, is superior to real-time. It can guarantee 500 Hz because instead of sending the command, so let's say in the Python we write move_j, we send just the values. So we've sent the values of pause or join values, and the commands themselves are defined in the polyscope program. And because of this, we can assure that that the program is executed with the correct frequency at the correct speed. So later on we are going to look onto the polyscope program, and it's going to have the following structure. Let me actually open it for you. So here on the right side you see the polyscope program, and on the left side you have the explanation. So our program consists of before start sequence, which basically is responsible for initialization of the variables. Then we have the main robot program, which runs our main control commands such as servo.j, move_j, changes the values of the registers, and implements control logic. Okay, and the most important thing is the thread. The thread is over here. This is basically a program running parallel to the main program, responsible for reading inputs from the register. So as we talked before, our program in Python is sending the values to the registers on the compute box, and the thread which is running on the polyscope is reading those values from those registers. And in this way we are able to update the values that we send to our functions such as servo.j as well as move_j.